We're going to do another example using probability trees now. So what we want to do is we have a vaccine has 90% probability of being effective in preventing a certain disease. The probability of getting the disease if a person is not vaccinated is 50%. In a certain region, 25% of the people get vaccinated. Draw a tree diagram to illustrate the above situation. And then we want to know if a person is selected at random, find the probability that he or she will contract the disease. So we'll start with the tree diagram. We're going to begin the tree diagram by focusing on the two regions. Either they're getting the vaccine or they don't get the vaccine. So here it says in a certain region 25% of the people get vaccinated. So we're going to call that the probability of getting vaccinated, so V, is equal to 0.25. So that's from the very last line. 25% of the people get vaccinated. Again, there's only two possibilities. We need to equal 1 here, so the probability of not vaccinated has to be the rest. 1 minus that, which is 0.75. So that's our first branch. Now, once we know they're vaccinated, we have to go ahead and say, okay, if you're vaccinated, the first line tells us there's a 90% chance, 90% probability of the vaccine being effective. So what we're going to say here is, if you're vaccinated, what is the probability that you got sick? So the probability of being sick here, you have already received the vaccine, so the probability that you got sick is 0.1. The probability that you did not get sick, so the vaccine worked, is 0.9. So hopefully you can see how that makes sense. So now we're looking at the people who did not get vaccinated. So if you don't have the vaccine, there is a 50% chance of getting it. So the probability of getting sick now without the vaccine is 0.5, and the probability of getting sick or not sick is 0.5. And so now we can really figure out, is there any point in getting the vaccine? So if a person is selected at random, find the probability that he or she will contract the disease. So we're looking for the probability of getting sick for either vaccinated or not vaccinated, because we're taking a person at random. So we have two branches to look at. We can look at this series here, get vaccinated but still get sick, or we can look at didn't get vaccinated and got sick. So those are the two branches that we're concerned about. Multiply along the branches, add coming down, and we find the probability of getting sick is 0.25 multiplied by 0.1 plus, so that's the top branches, and then the middle there we get 0.75, not vaccinated, and get sick is 0.5. We do that, and we find that we get 0.4. So the probability of getting sick is 40% for any person selected at random. We're going to add another question here. I want to say, what is the probability of having been vaccinated given that you did get the disease? Or you got sick, so I won't call it disease, we'll say sick. Alright, so now we look at a person, we know they're sick. Is it likely that they had the vaccine? Okay, well, that's going to be the probability of vaccinated and sick divided by the probability of sick. Now we already know V and sick is this first calculation up here. So that's 0.025. The probability of getting sick is what we just calculated, 0.4. So we divide those two and we see if you're vaccinated or if you're sick, the probability that you've been vaccinated is very small, 0.0625, or just over 6%. So that's another short little example continue along in the playlist or series of videos to see some more examples.